In early October 2025, as the United States government fell into a shutdown, and most of NASA's websites displayed a temporary suspension of public services notice. Something unprecedented in human history was unfolding more than 200 million kilometers away. The third interstellar object, 3I Atlas, was streaking past Mars. For the first time ever, a visitor from outside our solar system was being observed simultaneously from the orbit and the surface of another planet. Aboard the ExoMars Trace Gas Orbiter, the CASIS camera began the most daring exposure sequence of its operational life. It wasn't designed to capture a faint target moving at nearly 60 kilometers per second, but the science team tried anyway. When the first image appeared, a faint, ethereal dot was visible in the middle of the frame, the coma of 3I Atlas. It wasn't the solid nucleus, but the cloud of gas and dust sublimating as the object neared the sun. A colossal cloud, thousands of kilometers wide, glowing softly against the dark canvas of space, like a breath waking from a million-year interstellar slumber. In another orbit, the Mars Express spacecraft joined the hunt, with exposures of only half a second at a time. Its individual images showed nothing but noise, but after stacking hundreds of frames, a faint signal gradually emerged in the same position CASIS had recorded. It was the first time two ESA spacecraft had simultaneously seen an object from beyond our galaxy, and the moment scientists realized they were witnessing a historic event. But the marvels didn't stop there. Down on the surface of Mars, one of Perseverance's navigation cameras, or navcams, had accidentally recorded a thin streak of light cutting across the sky of Jezero crater. The navcam is designed for driving, not astronomy. But that night, it happened to be looking up, and in a continuous sequence of exposures. Its lens captured a line of light so long and symmetrical that many initially thought they were looking at an artificial object. Back on Earth, scientists scrambled to check the data. That streak, if converted to its spatial length, would be equivalent to nearly 50,000 kilometers, 1,000 times larger than the actual size of 3I Atlas. Something was clearly wrong. The Hubble Space Telescope had previously recorded the object as a tiny point of light, with no elongated shape whatsoever. This meant the streak couldn't be the physical body of 3I Atlas. It was an optical illusion. Even so, the value of the navcam image wasn't its shape, but its symbolism. It was the first time in history that a robotic camera on another planet had captured the trail of an object from beyond our solar system. A small moment, but one that opened up an entirely new era of observation. But this was just the beginning. Behind these blurry frames lay a complex scientific story. Why did a clearly active comet have no tail? Why was its image so stretched? And what made scientists believe that 3 Atlas was one of the strangest objects to ever pass through our solar system? To understand, we have to start with the basics. What is a comet? Every comet is a mixture of ice, dust, and rock. A dirty snowball traveling through the cold void as it approaches the sun. The heat causes the ice to sublimate, and the escaping gas drags dust with it, forming a hazy atmosphere called a coma and, sometimes, a tail stretching for millions of kilometers. But not every comet has a distinct tail. Some objects only exhibit a faint halo, especially if the viewing angle or timing isn't right. In the case of 3I Atlas, CASIS captured a clear coma, but the tail was virtually absent. This wasn't because it didn't have one, but because the tail was still too faint or was pointing away from the observer's line of sight. The camera system wasn't sensitive enough to detect the weak, bluish ion gas streaming from the nucleus. In other words, 3I Atlas was waking up, but it was still groggy. So, what about the streak seen by Perseverance? When capturing a very faint object, scientists must stack hundreds of short exposure images into a single composite to boost the signal. During that time, 3 Atlas was moving across the sky. Each frame recorded it in a different position, and when added together, its trajectory became a continuous streak of light. Because each pixel on the navcam covers a vast area, thousands of kilometers in space, Even a slight movement of the object translates into an image stretched over tens of thousands of kilometers. That streak wasn't a giant cylinder. It was a motion trail, the blur of time itself. To verify this, the analysis team compared the data with observations from the Hubble telescope and the Sphere-X observatory. Both showed 3I Atlas as a single-point source, with no elongated structure. Sphere-X even detected the absorption spectra of CO2 and H2O, the classic signature of a comet. The conclusion was clear: the streak from Perseverance was an optical phenomenon, not a physical structure. This led to a more important question: how big is the nucleus of 3I Atlas? Really, when you can't see it directly, scientists rely on its trajectory. An active comet is gently pushed off its standard Keplerian orbit by the jets of sublimating gas. The degree of this deviation reveals the force of the outgassing, which in turn can be used to infer the object's mass. For 3I Atlas, the deviation was surprisingly small. This meant either the outgassing was very weak, or the object was massive enough to be almost unaffected. A Harvard team led by Avi Loeb and Richard Kluda analyzed data from 227 observatories and concluded that the nucleus of 3I Atlas could be about 5 kilometers wide, with a mass of over 33 billion tons, if correct. This would make it 3 to 5 orders of magnitude, that is, thousands to hundreds of thousands of times more massive than Oumuamua and Borisov, a true interstellar giant. Still, NASA scientists remain cautious, since most of the light comes from the coma. No one can confirm this size until a higher resolution image is captured by HiRISE or CASSIS. The only certainty is that 3I Atlas is moving at an incredible speed, nearly 60 km, accelerating to 68 km as it reaches perihelion, its closest approach to the Sun. It passed Mars at a distance of only 30 million kilometers closer than any known interstellar object has ever come to a planet with active observers. This is why astronomers are calling it the first recorded interstellar encounter. Before 2017, most scientists believed that detecting an interstellar object was a once-in-a-lifetime stroke of luck. But in less than a decade, we've found 3. Oumuamua, the mysterious, Thales Enigma, Borisov, a classic comet from a cold star system, and now 3I Atlas, a high-speed traveler observed simultaneously from 2 planets. This succession cannot be a coincidence. It reflects a fundamental shift. Humanity has moved from an era of accidental encounters to one of proactive interstellar observation. The 3I Atlas observation campaign is the first proof of that new capability. The orbiters around Mars were mobilized in concert: ExoMars CASSIS, Mars Expresses HRSC, MRO's HiRISE, and even the Perseverance rover on the ground, on Earth. Observatories from Hubble to Sphere-X joined the effort. For the first time, humanity's entire interplanetary infrastructure operated as a single, unified network, aimed at the same target from beyond our solar system. This isn't just about science. It's a demonstration of global coordination in the new space age. If one day a dangerous object hurtles toward our solar system, the protocol tested during the 3I Atlas campaign will serve as the template for a planetary defense response: early detection, rapid mobilization, real-time data transmission, and parallel processing. Beyond the technical benefits, this discovery also reframes how we view the origin of life. If 3I Atlas carries a chemical composition similar to comets in our own Oort cloud, it suggests that the ingredients for planet's water, carbon, organic compounds are not unique to our solar system. They are the galactic standard. This implies that somewhere else, billions of years ago, a comet just like this one could have seeded the first atoms onto a young planet, starting the chain reaction that led to life. Some scientists, like Suzanne Falsner, go even further. They propose that objects like 3I Atlas could act as planet seeds, pre-existing cores that fall into the protoplanetary disks of young stars, helping planets form much faster than standard models predict. If true, the galaxy is actively exchanging material between star systems, and every world may be born from the remnants of another. Conversely, Avi Loeb maintains his more controversial perspective that some interstellar objects could be technosignatures. He points out that, as with Oumuamua, every natural explanation requires us to assume the existence of a type of object never seen before. While his view faces significant opposition, it forces science to ask a critical question when faced with a completely new phenomenon. How much evidence is enough to dare consider an extraordinary possibility? Whichever side you're on. 3i Atlas represents a meeting point between reason and imagination. It proves that to understand the universe, we need not only technology, but also humility, the acceptance that sometimes the faintest glimmers hide the biggest answers. And as 3 Atlas continues its journey toward the sun, it leaves us with a legacy not just of data, but of inspiration that humans, however small, have learned to cast their gaze across 2 planets to follow a speck of dust from another part of the galaxy. But its journey isn't over. Even bolder theories are waiting. Are objects like this just random debris? Or are they messengers carrying a deeper meaning? In the world of astronomy, 2 theories are currently running in parallel. The first is the planet seed hypothesis that interstellar objects like Atlas could be the initial nuclei that help new planets form in other star systems. If true, the universe is not just expanding, but also sowing seeds. These wandering fragments are the means of planetary rebirth. The other, more audacious theory is the technosignature hypothesis that among the billions of objects flying between the stars, some might be artifacts created by other intelligences' ships, or their fragments, that have drifted for millions of years before entering our view. These 2 theories are not mutually exclusive. They both reflect a single truth: we are beginning to understand that we are not isolated in the universe, at least not materially. Every interstellar object is a thread connecting star systems, proof of a galactic exchange of matter, whether natural or artificial. As the observation campaign continues, researchers eagerly await data from HiRISE, the most powerful camera orbiting Mars, to determine the true size of 3i Atlas's nucleus and search for signs of fragmentation. We may not get the clear view we hope for. The distance is still immense, but that doesn't matter. What matters is that for the first time, we were prepared. We observed proactively instead of just chasing a ghost, as we did before. From now on, every time a new interstellar object is detected, we will have a plan in place not just on Earth, but on Mars as well. And perhaps, when humans set foot there in the next decade, they will be the first direct witnesses to see a messenger from elsewhere fly across the red sky of that planet. 3i Atlas is now heading toward its perihelion, expected in late October 2025. Afterward, it will depart our solar system, carrying with it unanswered questions. But the legacy it leaves behind is enough to open an entirely new field of study: interstellar astronomy. And it's possible that in the coming years, when the Vera Rubin Observatory begins operations, we will no longer speak of 3 ISOs discovered, but of hundreds, even thousands. When that day comes, 3 Atlas will be remembered as the beginning of a data flood, a revolution in how humanity understands its place in the cosmos. And now, a question for you: if you could control a camera on Mars for 30 minutes, where would you point it? At 3i Atlas? Or at the star-filled sky behind it? Do you think this object is just an ordinary giant comet? Or is it, as many journalists have called it, a messenger from the void? Leave a comment, share your thoughts, and don't forget to subscribe to follow this strange journey until it disappears back into the darkness. Because maybe 3i Atlas isn't the last visitor, but just the first greeting from the rest of the galaxy.